Good day, everyone. Welcome to Jamovi for Educational Research Tutorial Series. Ep.3 Paired Samples T-Test. What is paired samples t-test? The parametric paired samples t-test, also known as the dependent samples t-test or repeated measures t-test, compares the means between two related groups on the same continuous dependent variable. Here are the assumptions of the parametric paired samples t-test. The dependent variable should be measured on a continuous scale. The independent variable should consist of two categorical, related, or matched groups. The differences between the matched pairs should be approximately normally distributed. And there should be no significant outliers in the differences between the two groups. A researcher wants to determine if exposure to a certain intervention or the independent variable can change the dependent variable by comparing the pre-test and post-test. Here is our sample situation. Teacher Romel wants to conduct a study to determine the effect of using frequently occurring mistakes of students or FOMOS video lesson on students' performance on operation of integers. He administered the pre-test prior to the intervention and conducted a post-test after the students completed watching the video lessons. Here are the tasks that we will go through in this tutorial. Perform the test, check the assumptions, interpret the results, report the analysis. Once your dataset has been successfully imported in the Jamovi software, you're now ready to perform the test. So make sure to keep your focus on the process. Let us now begin. When it comes to the interpretation of results, these are the parts that you have to pay attention to. For the paired samples t-test results, always look at the p-value, which should be less than 0.05 for it to be significant. Effect size is also a must check, since it helps us understand the magnitude of differences found, whereas statistical significance examines whether the findings are likely to be due to chance. So since we're dealing with the difference between two means, we are using Cohen's t. Here's the guide for interpreting effect size for t-tests of means. If you got 0.2, the effect size is small. If you got 0.5, the effect size is medium. And if you got 0.8, the effect size is large. For the normality test, as you can see, there's a note below the table stating that a low p-value suggests a violation of the assumption of normality. To meet this assumption, you should obtain the p-value of greater than 0.05. If you get less than 0.05, it means that the assumption for the test of normality is violated. If that is the case, instead of paired samples t-test, use its non-parametric counterpart or alternative, which is the Wilcoxon signed rank test, which we will discuss in our next session. For the descriptive statistics, you should report the values for mean and SD or standard deviation. This analysis report follows the APA format, provided with the tables of results for inferential statistics, descriptive statistics, and the assumption for normality test. This is how you should report the analysis in order. Take note of the terms in blue font and the format of reporting values in red font. The main objective of this study is to determine the effect of frequently occurring mistakes of students or FOMO's video lesson on students' performance on operation of integers. The performance on operation of integers was measured using a 50-item teacher-made test. Prior to conducting the analysis, Shapiro-Wilk statistics was computed to examine the assumption of normality for paired samples t-test. The result of Shapiro-Wilk test showed that the assumption of normality was not violated, represented by the given values. The result of the paired samples t-test reveals that there is a significant difference between the student's performance on operation of integers before and after conducting the intervention, represented by the given values. The effect size for this analysis, with a given value of 0.88, was found to exceed Cohen's 1988 convention for a large effect. The findings suggest that using frequently occurring mistakes of students or FOMO's video lesson as an online asynchronous performance tool has a large significant effect on students' performance on operation of integers. That ends this session. Thank you for watching Jamovi for Educational Research Tutorial Series. Stay tuned for the next episode. See you next time.